The following content has been provided by RWTH Aachen University.
The star came out also done by Park in '81, so 8 years later. And this basically made the Windows system available commercially. So this was the first commercially available graphical user interface computer, but not the commercially successful computer. Because it was basically just too expensive. You know, $17,000 was not something back in 1981 that somebody would just take and spend on a machine that might help them in their office. However, the Star added a couple things to the Alto beyond the graphical user interface with, like, you know, icons, etc. It also added an integrated network document environment, so you could actually access documents on a file server in your local network. Using Ethernet, of course, because it had been invented at Park as well. It offered a WYSIWYG text editor, icons, property sheets for things, the management of windows, you know, moving windows around, and all those kinds of things. What was probably most unique about this Star was also that it took a very user-centered process of determining what the interface should actually look like. So they took the Alto and spent 8 years of really revising the graphical user interface and improving it from scratch. They would take, you know, the icon designs, because they didn't know what a graphical icon for a document should look like. So what is it going to be? So they tried all these alternatives with actual users, you know, people who would do office workers, secretaries and the likes, who would be using those kinds of systems, and determined the whole visual language, if you like, of graphical user interfaces that has largely stayed around until today. This is the introduction of the graphical user interface and bitmap displays that Nielsen refers to as sort of a 2.5 dimensional interface, saying that it's an interaction that allows you to work on a 2D space completely, even with some sort of, you know, suggestion of a z-axis ordering of stacked windows, for example, overlapping windows and stuff like this. There's also a video on this system, and I'll show you this because it is a wonderful demonstration of the Star. And what I'd like you to pay attention to is which of the interactions that you will see here are things that you still do this exact same way today. So they've basically really defined what we still do, you know, 20, 30 years later. And, you know, look at the year, right, 1981. This was the year that IBM released its PC, right? The boring sort of alphanumerical keyboard, alphanumerical display one. So look at what still works the same way today. And then there are some things that you will find strange, you know, things that where you're like, wait, that's not how a desktop works. And I'd like you to also pay attention to those differences in the metaphor, how the metaphor has been changed since the Star to today's graphical desktop environments, because it, you know, didn't work that well in that format.
The following videotape was made in 1982 by two Star designers. It illustrates some of the innovations in computer-human interfaces embodied in the Xerox Star.
Okay, so from, I think, this presentation, we saw a couple of things that you know, or most of the things, I guess, are pretty much standard, right? So you're like, okay, yeah, that's how we do it today, so what's the big deal? What were things that struck you as unusual? Do you notice anything that seemed to work differently from how we do it today on our computers? Yeah.
Printing was highly integrated into the operating system, meaning you couldn't let all the application couldn't provide a menu for printing. Instead, you had to, like, drag the icon down to the printer and get a system menu.
Right, right. So you printed from the desktop, essentially. You didn't print from inside an application, yes. And then there was also no print command, but simply by dragging and dropping. Yes?
There were a lot of special keys when we would use context menus today.
Most definitely, yes.
And they have also some, when he marked the text, he has a double click, a triple click, and also a quadruple click. And I think he can do it he did it very slow. So
there's no timeout, right?
There's no timeout, so if you have clicked it once and will want to do something other.
Yeah, that was definitely different from how it works today, right?
I think today there's no quadruple click anywhere. At least in my PC it is.
Yeah.
Triple click is still most of it.
Yeah, triple clicks though still often exist. Yes, that's a good observation. Both that this is something that is still being used as a general metaphor, but the very slow timing is something that today these systems often time out after a while, and then your double or triple click won't do the same thing anymore, but it will actually start again selecting something. You mentioned the special keys. That's a very important part of that I want to point out to you guys. The fact that there were actually dedicated keys for some operations, like moving or copying things, or the thing that we know today from applications like Word, that is basically the little paste thing, the little brush to say, I want that design to be the same as that design, like apply formatting to a different paragraph. That had its own dedicated key. So you notice also that the keys on the right had one of my favorites, which is the big red stop button. I'd love to have one of those on my computer these days. Just stop what you're doing. And it was also clear that this was an office machine, right? It was done for office design, so font and margins had their own hardware keys, as did all the different formatting options like bold and underline and so on. So very clearly made to create office documents, which was one of the problems actually from the start, because it turned out that it wasn't very flexible. It wasn't really designed to be a general purpose computer. It was really designed to create office documents. The other thing that I think was interesting, if you notice this, on the desktop, he talked about file names, right? And that's one of those things that I think was just a little unusual. Yes?
The file names doesn't need to be unique.
Exactly, they don't have to be unique, right? Today, we're completely used to the fact that, of course, you have to use different file names. How could you possibly put two things with the same file name into one folder, right? Your computer is going to blow up. Well, if I take two physical files and put them into the same physical folder on my desktop, that folder doesn't blow up. Right? So why should it on the computer? That's just because the mainstream sort of commercialized versions of the PC and what came afterwards just used these very simplistic, really, file systems that just couldn't deal with where the file name was the individual identifier of that thing, right? But when you think about it, that's really overloading it. The file identifier for the computer is one thing, to keep one thing straight from the other. But the name that you give to a file is really a description for humans to read. And that shouldn't really be the same thing. And here in the start, it wasn't. It said, well, I can have two files that have the same name. That's fine. I can distinguish them by the date that they were created. That's perfectly OK. So those are things to keep in mind. When does our view of technology, when does it get so ingrained in our understanding that we actually ignore the fact that it's actually limiting us in doing things the way that we would like it to do? And apart from the fact that these file names didn't have to be unique, that was one thing that was definitely different from what we know even today, and which is a strange limiting factor. I think also the way that the inbox and outbox of email were integrated into the desktop, right? Your inbox and outbox were things on the desktop, right? And you could click on them and they would open up. Again, kind of like the printing, it was just built into the system rather than being its own dedicated application. Today, when you install a computer and the operating system, when you want to do mail, you have to launch a dedicated application for that. Otherwise, you're not seeing your mail. And so this was a little different here. Things were more interwoven with each other. Some of the things, and we have a report on that for you guys to read. There's a very good paper. Oh yeah, go ahead.
I didn't get quite the difference between folders and drawers on that previous model.
Yeah. The folders were, as far as I understand the interaction design, a local sort of structuring, and the file drawers were actually storing things on a server outside your actual local machine. That was my understanding of what the difference between those two were. Yeah.
And I have a question to your virtual keyboard. Do you have to press the real keyboard and it will print an omega, for example, or do you select it with your mouse on the screen?
I don't know. I'm not sure. My hunch would be that you still press the normal keyboard, because I noticed with something that was actually better than today's virtual keyboards, when I turn on like the character viewer on the Mac, or the keyboard view on the Mac, I can see these special characters that are on a keyboard when I press like an option key. But on their keyboard, you could still see the actual letter, the normal letter that would be on the keycap, in small print in the corner of each key. So that's probably there in order to allow you to type these physically. So you see, I don't know, the kappa symbol is on the K key, so I know I need to press the K key to get it. That's why I think that was probably operated by the keyboard. Maybe you could also click on it on screen. There wouldn't be anything to keep you from doing that. So not something I could tell from the video, though. Some of the things that were really interesting, and you'll see this in the paper that was written about the design of the star, which is a really nice review of the actual process that happened, is that they really changed the way that people were designing information technology. This was the first time in history that they understood the principle that we're now teaching as the standard process. You know, design first, think about what you're building, prototype, talk to users, figure out what you actually need to do before you write code. I know some computer scientists, still like to start writing code. But this is sort of the process of having information from the user, the task, and so on, before getting started. Another thing is objects and actions. When you think about a command line interface, you type in move, so you give the command, and then you type in the first object and its destination or something. That's a clear like action object structure. Many initial attempts at graphical user interfaces, and sometimes you still see them, try to be a graphical user interface, but they really are still action object interfaces. I think the Eagle layout software for PCBs is a great example. You first pick a command, and then you pick the object to apply that command to. The danger of that is, once you pick the command, it's very easy to pick the wrong object and then have disastrous things happen. Right? You pick the delete command, and then somebody calls you on the phone, and you answer the phone call, you go back, you click somewhere, and all of a sudden you deleted something you didn't want to, because your system was in a mode. And as we know from the discussion of Norman's books, modes are not a good idea. So when you do object action instead, so you first pick an object of interest, you select a file, for example, and then you say which command you want to issue on that file. That's a somewhat safer way of operating. Also makes it very easy to say, oh, I want to select this file, and this file, and this file, and this file. Now I have a selection of a couple of files, and now I'm going to apply a connection to them, like deleting them or moving them. That's very hard to do from an interaction standpoint if you first pick the command and then you have to specify the objects, because then you need sort of a delimiter to say when I'm done with my selection of the objects. It all gets trickier. They paid a lot of attention to detail in designing these icons, as I mentioned already. And we had the fortune of having Bill Verplank, one of the graphical designers of the Star user interface, here a couple years ago. He's a good friend of mine. And he gave a course in graphical sketching as part of this, as part of a special class. You can still catch a video of that, and I'll point you to it once we get to interface sketching in a couple of weeks. The graphic designers that were involved in the team were also a novelty, right? You actually had people on there who knew about visual design, not just developers and technologists. And the whole DIA cycle, which we will be covering in this class, the cycle of design something, build a prototype, and analyze it with users. Design, implement, analyze. Design, implement, analyze. This whole iterative fashion. Agile development is the word in software engineering these days. That was something that these guys pioneered. However, the Star didn't really work out. It didn't become the glorious success that made Xerox even richer. First of all, it kind of missed the boat on a couple industry trends. The industry was currently heading for the PC. The PC was a fraction of the cost. Everybody was buying IBM PCs, installing DOS on them, and happy enough with the simple way of using VisiCalc and the other tools on there. They just weren't quite ready for this. The focus on customers was also not quite there. They developed this for the perfect office work situation, but they missed the boat that a lot of people wanted to do other things with their computers than just creating beautiful documents. Maybe Xerox, the document company, was a little limited in their view there. They also found that they had designed the star not as a very extensible system. It wasn't actually, get this, the star was a computer that you bought that had no provision for installing additional software. You bought it as the box that you used to view your documents, and all the software came from Xerox to install on it, right? There was nothing, there was no way of adding stuff to it. It wasn't planned to be extensible that way. And that was missing the boat again, because the IBM PC was the ultimate. It was completely useless when you unpacked it, right? Until you started installing applications. Responsiveness was also an issue. So, it was just slow because, hey, they were running Smalltalk, an object-oriented language and environment on this. So did you notice when when the property sheet appeared, the guy actually had time to say, and now you see a property sheet appearing in the lower right-hand corner of the screen. And all the time while he's saying that, the property sheet gets drawn, the buttons get filled in. So this was really, felt a little slow. Also, the desktop metaphor did have its limits, and they were the first ones to create this desktop metaphor, but they also were the first ones to run into the issues like, when does it stop working? When are the things that don't quite work well with the desktop metaphor? And they just had to discover these. Well, and then there's a business wisdom that says, like, if you are the very first to come out with a radically new idea, you're probably not going to make money because it's so radical that the customer base may just not be ready for it. So sometimes you have to be a little later in the time, but get it right and get people's expectations matched better. This was very different from what people had seen so far. Remember, the star came out the same year the IBM PC appeared, right? So this was a far cry away from people. They hadn't been working with standard PCs for years and now saw this graphical interface. No, they'd never seen a PC, never seen any computer on their desktop, and then you came along with this.
This content was provided by RWTH Aachen University.